So what we are looking at today is the rectangle. One of the things that you have to consider is that a rectangle is a special type of parallelogram. So the properties of the parallelogram will still apply to the rectangle. So what I'm going to do is just pause the video for just a second, let you try out to fill in the first 5 properties just from memory. Okay, so hopefully you are to the point where you can kind of train your brain to work through some of these things. So the opposite sides, since we're looking at a parallelogram, the most obvious opposite sides are parallel. Once you get the opposite sides are parallel, what else about the opposite sides? Well, the opposite sides are also congruent. And then you would ask yourself, what else is congruent? Well, those are opposite angles. And then what else about the angles? Well, the angles, consecutive angles, are supplementary. And then last but not least, the kind of oddball is that the diagonals, they bisect each other. Okay? So again, all of those properties will still apply to our rectangle. So again, opposite sides are parallel. We can mark those. We've got opposite sides are congruent, so we have those are going to be congruent. Opposite angles are going to be congruent as well. So again, each of those are 90 because it's a rectangle. Therefore, they're also supplementary. And then your diagonals bisecting each other. So again, we have those little pieces here and here. So those all still match up. Now, some new properties that apply to rectangles. First off, a parallelogram with 4. You guys probably already know this. It's a rectangle, so if you look at all the corners, all of those are right angles or 90-degree angles. So those are 4 right angles. So in other words, every single angle in a rectangle are 90 degrees. We can do that all the way around. So to find x for this first one, we would just set 3x minus 12 equals to 90. And then once we go ahead and solve, we would have 90 plus 12. And then take that sum and divide it by 3 to get an x value of 34. The other case here, if we look at this, for example number 2, there's more than one way to do this, but for me, I know personally, I would recognize this is a right angle, and I've got a triangle going on here. And so I would go ahead and add 90 and 54 to get 144, and I would do 180 minus 144 to get us 36. Okay. Now, as far as what do you know about the slopes of opposite sides of all parallelograms? Since we're looking at opposite sides, we need to make the connection that opposite sides are parallel, and if we have sides that are parallel, that means that they have the same slope. On the second question, what did you discover regarding the slopes of consecutive sides of a rectangle? So as you guys look at either coordinates, or if you just think about this logically, if they are right angles, that means the sides are going to be perpendicular. And if the sides are perpendicular, that means that your slopes are going to be opposite reciprocals. Kind of going back to what we already know about lines. All right? So in other words, if you look at this, if you have a rectangle that has a slope of negative 2/3 for a side, when it says up above, it is referencing this very first one all the way back at the beginning. So again, if CD is negative 2/3 for a slope, they're asking you then, what is the slope of AB? So if I look, AB is the opposite side. So the opposite side is going to be the same. And then BC, if we look, BC is a consecutive side, meaning, again, we have to have that right angle going on. And so if your CD is negative 2/3, we change our sign to become a positive, and we flip our fraction. Okay? So here's the deal. If you guys look at the coordinate intro on a rectangle, what do you observe regarding the length of the diagonals? So hopefully you guys recognize that your diagonals in a rectangle are going to be congruent. So again, we still have that the diagonals bisect each other coming from the fact that it's a parallelogram, but now we also have this additional property that those diagonals are going to be congruent. So if we look at this, if RT is 14 inches, again, that diagonal is bisecting each other, so that means that this piece is going to be 7, this piece is going to be 7. Because it's a rectangle, these are going to be congruent sides. So again, all of those pieces are 7 and 7. So RB is 7, BT is 7, QB is 7, and BS is also 7. So all of those are going to be exactly the same. Now, if we look at example number 4, I'm going to let you guys kind of work through this and see if you can figure out your answer. Okay, for example number 4, you know that SQ is 24. You also know that BQ is 5x minus 18. So if this is 5x minus 18, we can know, because again, the diagonals bisect each other, we can know that QB is 12 because it's half of that 24. So we can do 5x minus 18 equals 12. Or some of you might have gone the route of saying, well, if I know this is 5x minus 18, so is this. So you could have done 5x minus 18 plus 5x minus 18 equals 24. Either way you do that, when you solve, you get an x value of 6. Okay? Moving on to the next example. So this is including angles and side lengths. So let's start with just the sides. So if DB is 42, which is what it gives us in the information, and AD is 26. Okay, so let's pick out some pieces. So AC is this other diagonal. So again, because it's a rectangle, we know that the diagonals are congruent. So that's going to be 42. We know that EB is half of that. So that's 21. BC is opposite the AD. So again, this is going to be opposite the AD that we already know. So BC is going to be 26 also. And then it asks for AB. AB, if we notice here, we have a right angle, so now we have a right triangle. So let me just draw this out. You've got 26 for this leg. You don't know this leg, but you know the hypotenuse is 42. So now we're back to using Pythagorean theorem with the 42 being your hypotenuse. So now when I type this in, I've got 676 here. 42 squared is going to give us 1764. When I subtract 676 from that, I get x squared equals 1088. And then when I do the square root, I get a value of approximately 32.98. Okay, so again, we have to keep in mind that now we have right triangles at play and we could be using our Pythagorean theorem. Let's talk about angles. So if we look at DAE, so again, we're going to trace that. DAE is this angle in the corner. This is 52. Technically, we can come up with every other single angle measure in this rectangle knowing that's 52 and knowing that it's a rectangle. So first off, I'm going to go ahead and close this off and recognize that if this is congruent to this, that means we have an isosceles triangle. So if this top angle is 52, so is this. And these two triangles on the side are identical. They're just folded over. So this is 52, and this is 52. Now what we can do is we can figure out the angles next adjacent to those 52 by doing 90 minus 52, which gets us 38 at those corners. Okay, so we have 38, and again, the triangle on the bottom is exactly the same. And then I'm going to just talk through this part, but we're going to figure out the angles in the middle by either using the triangle on top to figure out the vertex angle, the triangle on the right, triangle on the left, or triangle on the bottom. And then we could either use vertical angles or linear pairs. We're going to talk about that, but I don't want to clutter my picture too terribly much. So ADC, if I'm going to trace that, ADC is the big angle here in the corner. That's my 90-degree angle. ABD is, again, this angle up here in the corner, so that's going to be 38 degrees. BCA, so if I go from B to C to A, that's going to be the 52 degrees in that corner. And then DEC, so DEC is this angle here. So what I can do is I'm going to go ahead and finish that triangle out, and I can do 38 plus 38, which gives me 76, and I can do 180 minus 76, which gives me 104 degrees. Okay, so when we look at the next example, I'm going to let you try both of these out on your own first. So go ahead and do both examples, and then we'll walk you through the answers. Okay, so when we look at this one, we have Jn given to us, and we have Nk. We know that those two are equal, so we just set them equal. So that's going to be 4x here. That's going to be 40 on this side, and so we get an x value of 10, but it doesn't ask you for x, it asks you for JL. So what we're going to do is we are going to go ahead and we are going to plug in our value for JM. So we get 10 plus 17, which is 27, but that's both of these pieces, so therefore JL is going to be 54. Okay, for X, this one is maybe a little bit more difficult, but when we look at this, we're going to use the 134 to figure out the adjacent angle, which is 46. And then we can use the idea that this is an isosceles triangle. So you can do this several different ways, but if that's 5x plus 7, so is this angle. So we can do 5x plus 7 plus another 5x plus 7 plus the 46 in the middle equals 180. Because again, we have a triangle. So we can combine our like terms. So we have 10x, 7, and 46 is going to give us 60. And then to finish solving, we have 10x equals 120, so our x is 12. Again, there's more than one way to do that problem, so don't feel like you have to do it the way that I just showed you. Okay, so guys, here's the deal. Again, just be mindful that all of the properties we've already talked about for parallelograms still apply for rectangles, plus our additional two that we talked about already. One being that you have right angles at all the corners, and then the second thing that all of your diagonals are congruent. As always, ask any questions that pop up. I'd be happy to help.